SwayamPrabha. Digital India. Educated India.
So, friends, in the course on production and operations management, we are discussing project management. In the first session on this particular unit on project management, we discussed what is project, why project need to be efficiently managed, three goals of the project management, that is within the budgeted cost, within the time schedules, and technical performance of the project are important for the successful completion of the project. We also discussed the various stages in the project implementation, starting with planning phase, then we said scheduling, then control, and then termination of the project. All the 4 stages are very important. Several decisions need to be taken at each stage, and so that the project is successfully completed. We also discussed the various risks associated with the projects, and then also talked about the various kinds of appraisals: technical appraisal, commercial appraisal, economic appraisal, financial appraisal, managerial appraisal, and social cost benefit analysis of the projects. After having this discussion and on initial aspects or planning aspects of the project, now we are talking about the stage 2 level activities, that is scheduling of the project. So, scheduling the project is very important, because after having the scheduling of the project, you get to know what is the start time of activity, what is the finish time of activity, and based on that you can mobilize the various resources in terms of human resource, in terms of equipments, in terms of expertise skills required, or some kind of equipment is required, or any other aspects which is required to completion of the activity. All these are going to be worked out with the scheduling. Also, with the help of the schedules, you will get to know what is the project completion time, what is the total project duration time, and during this activity itself, in determining in project scheduling, you will also get to know what are the critical activities of the project, the activities which should be given utmost control, which should be given utmost attention, because any delay of the critical activity will delay the overall completion of the project, whereas there may be certain other non critical activities also, for which we are having certain slacks available, which we can use for the various purposes. We can depending upon the requirement of various resources, leveling of the various resourcing can be done with the help of the floats available or slacks available with certain non critical activity. So, that is the whole aspect of this scheduling, and in this 2 important techniques which we are going to study are critical path method, that is CPM, and PERT, that is program evaluation and review technique. Also, a Gantt chart is very important, which we have also studied at in the scheduling and sequencing, that is the time activity graph, the timings of various activities which are represented on a graph on a horizontal bar chart. So, Gantt chart also we will see in this particular scheduling aspect. So, what is project scheduling? Project, as we know that project consists of several activities, and these activities are interrelated. These activities are interrelated due to some logical relationship. You cannot do a certain activity unless some other precedence activity is completed. All these activities require resources of 3 types: time is required, human resource man is required, and material and equipment is required. By doing this scheduling, we get to know that at what time a particular activity is going to be performed, and then accordingly what is going to be the manpower requirement at different stages on different days of the project, and what type of equipment and materials are required at different time periods in the project. Then project scheduling is developing operating timetable of the project, the start time and finish time of the various activity. So, that is more like a timetable that on from day 1 to day 7 we are going to do this activity, day 7 to day 20 we are going to do this activity. After the third day of the first activity I can start some other C activity also, like this. So, it gives you the complete timetable for various activities. It also identify the precedence relationships also. Yeah, that means you have to have complete a particular activity prerequisite, then only you can start the other activity. So, that is called prerequisites or precedence relationship. Then it will sequencing activity also, it helps in developing the sequencing also. Project scheduling is a sequencing activity. In the process we develop the sequence of the various activity, in what sequence the various activities are going to be performed. So, that there is a clarity, there is no ambiguity when a particular activity need to be completed. So, scheduling helps to a large extent in removing the ambiguity in the implementation of the project. If the scheduling is done very rigorous manner, you will find there is a very high degree of clarity in the implementation of the project. It reduces the ambiguity. Then determining the activity times and cost also, we can determine how much time an activity will take and how much cost is going to be incurred in completing the activity. There is a we are going to study that also. There are certain activities which can be shortened, which can be crashed. The term used in project management is crashing. That the duration of the project can be reduced by adding some little more resources that may help, that may increase the cost of the project, but by increasing the little bit cost of the project we can shorten the duration of the project. Then as I said, the scheduling helps us in estimating the materials and workers requirement. How much material at on a particular day, particular week is required, what is going to be the manpower requirements on different days or different weeks of the project. It also helps us in determining the critical activities, the activities which need utmost attention, they should not be delayed. The steps involved in project scheduling: identifying the activities, tasks need to be performed to complete the project. We have to list all the activities, tasks which are required to be completed. We should not miss any activity that may create later on problems, conflicts and other things. The contractor may say that you have not specified this particular activity or this particular task. So, at that stage it becomes very difficult to revise the tender requirements or additional budgets may be a problem at that stage. So, you must identify each and every activity or task which are needed in the completion of the project. Determining activities, time and cost. Once the list of activity is there, based on the our past experience, we can determine how much time an activity will take with the certain amount of resources and then how much it will cost in completing that particular activity. Estimating materials and worker requirements. We will estimate how much material is required on a particular day, in a particular week, and workers requirement also. Establishing the precedence relationship from the logical interrelationship. So, we will develop the which activity, we may say that activity D can start only if A and B have been completed. So, that is called a logical interrelationship or precedence relationship. Activity D can start only if A and B are completed. So, that kind of statements, and then we will convert them into a network diagram also. Develop the network diagram also. We will study two types of network diagrams. One is called activity on node and another is called activity on arc. So, two type of network we will learn here and they are having different application, but most of the time we will use activity on arc. But to begin with, we can develop activity on node network, which is very easy to construct, but for the purpose of CPM and PERT analysis, we are going to use activity on arc network. Then sequencing the activities using techniques like critical path method, CPM, and program evaluation and review technique, that is PERT. So, that is going to be a major part of this particular session, and the next session we will discuss CPM and PERT techniques of sequencing. Then determining the critical activities, rather a critical path method will help, will give you two outputs. One is it will tell you what is the project completion time, what is the length of the longest path, that is the critical path, and from that we will get to know what is the project duration or the project completion time. It also help in finding out the critical activities, rather it divides all the activities into two categories. One category is critical activities and the another category is non critical activities. So, it will divide the activities into two parts, critical and non critical activities. So, that is the next step. Then developing the time cost trade offs also. We for when we are determining the critical activities, we also calculate the floats or slacks available for non critical activity. Slacks helps us in planning the manpower, equipment and materials also, because these activities can float in certain duration. When we say float, you can visualize from this particular aspect. There is an activity, let us say activity. Activity has a duration of activity duration is let us say 3 days. It can start on day 5 and it must finish by day 15. This is the called early start time of this activity. This is called latest finish time of this activity. So, we can plan this activity from 5 to 8, 3 days here, or this activity can be planned here also, 3 days can be planned here, or it can be planned somewhere here also. So, this activity of 3 days can float in this particular period, or it has a slack, it can shift in this particular period. So, that is called, that is the concept of, but this is for non critical activity. This is for non critical activity. The critical activity does not have any a float or slack. This is for non critical activity. The critical activity does not have any float or slack, they do not have any cushion. If it is get delayed, whole project will get delayed. So, here along with determining the critical activity, we will calculate the float and slacks of the non critical activities also. Then we will do the time cost trade offs, in the form of project crashing and the resource leveling. We are going to study that also, and monitoring the project with the help of Gantt charts. So, we will talk about that also. So, these are the various steps for the project scheduling, and we are going to take up one by one. So, another aspect which you have to keep in mind, there are several projects may be going on together of the same parent organization, or by the contractor also, or maybe by subcontractors also, or maybe the other equipments etcetera are going to be used by several projects. So, these resources compete with each other each other projects. So, that is why the scheduling is very important. And the resources are of two types, just I said that not consumed equipments type of lift, equipments like lift or other various cranes etcetera, which are used in construction of metro in the, and then scaffolding etcetera, which are used in construction of building etcetera, the materials which are not consumed. And then obviously, the materials which are consumed, the steel, cement and other such materials or electrical items, wires etcetera, and so on. So, these are the materials which are consumed. So, each project has requires materials, consumable materials as well as not consumed material. So, we have to see that these resources are available. The scheduling will help us in finding the requirements of these resources. Goal of resource allocation is to optimize the use of limited supplies. So, we should allocate the resources. Maybe you are having let us say 10 workers available only, but in as per the schedule, on certain days 15 workers are required, on certain days 3 workers are required, on certain days 7 workers are required, like this, but you are having a maximum workers available are 10. So, in that case you have to readjust the trade off between the time and resources you have to make. So, that you are not scheduling more than 10 workers on a particular day. So, that is what we have to do, that if there are some certain resources are in limited supply, then we have to do the trade offs of time and cost and of that resources. So, that resource constraints are considered maybe by rescheduling of the certain activities. And this in the rescheduling process may sometimes lead to increase in the project duration also, but in some cases within the same duration also we can do the we can meet the resource constraints without extending the duration of the project. But in certain cases yes, there may be a case where the because of the resource constraint the project completion time may get extended. But we should be knowing beforehand that this is happening because of the resource constraints. And there may be a time constraint also where the project need to be completed by a particular date. In that case, if there is a time constraint, but resources are available at a higher cost. So, we can mobilize the resources, more resources, slight increase in the cost also to meet the time constraints also. So, that is called this if you are if there is a time constraint for project completion, that particular aspect is called project crashing. We will crash the project, we will reduce the duration of the projects by reducing the duration of certain critical activities, and if there is a resource constraint, we have to do the resource leveling. Okay. So, these are other aspects of project scheduling. So, as we are discussing, as we are I am informing you, there are three more important techniques which are we using in project management. Gantt chart, as you have seen in scheduling sequencing unit also. Gantt chart is nothing but this is your activity A, then this is the activity B, then this is activity C, there may be activity D also which is going on, there may be activity E here like this. So, this is time versus activity graph. There is some activity which is happening here, there is certain activity which is going on here like this, like this. So, this is your nothing but a Gantt chart. So, these are the various activities which are required in the completion of the project, and this is where you are saying that project is complete. So, these are the various activities which are kept, and then you can do a review on a particular review time. Let you are doing that, this is your review, and on this review the actual performance of the activity may be different, though this activity should have been completed, but this activity is still going on. This activity is still going on. Okay. So, like this. So, and similarly this activity should have been 60% complete, but in actual it is yet to start. This will this has not yet started, though it is expected to be completed by 60%. So, this is how the Gantt chart helps. This is the red color is the planned one, red color is the planned one, and on this the actual performance can be drawn, and then the two thing can be compared. So, that is the Gantt chart, and then as we have said, critical path method and program evaluation and review technique we will have. This is a Gantt chart which I have just shown to you, and on a particular review period, if we are talking about, let us say we are reviewing the project at this point of time, and at this review time we found that these activities should have been completed of certain extent, and but some delay, or there may be case this activity which was supposed to start in the month of June has already started. So, we can expect that project will be completed even before due date. So, all these things get reflected with the help of Gantt chart. So, what is Gantt chart? Simply put, a Gantt chart is a visual view of tasks scheduled over time. Gantt charts are used for planning projects of all sizes, and they are a useful way of showing what work is scheduled to be done on a specific day. This is a specific day, let us say we are talking about 20th of May. Okay. And they also help you view the start and end dates of an activity in one simple view. So, for a design, this is the start date, this is the finish date. For a prototype, this is start date, this is the finish date. For testing, like this, and for revision if any is there, like this, and then production can start from once the design is handed over, production can start. So, that is the kind of a Gantt chart, very useful and very simple presentation of the activities, scheduled activities and actual activities. Now, coming to the PERT and CPM, they are network techniques. We will develop the network, and they are developed in 1950. CPM by DuPont for chemical plant, establishing the chemical plant in 1957, and PERT by Booz Allen and Hamilton with the US Navy for the missiles development. So, you will see that chemical plant is more deterministic activity, whereas missile development is more probabilistic activity, R&D activity. This is more like a construction project, this is more like a R&D project. They consider the precedence, relationships and interdependencies. CPM is generally used for projects where activity durations are known, being the repetitive activities. Mind it, these are the activity, repetitive activity. Project is unique, but activities are repetitive in nature, and but activity, the volume and size of the activity may be different, but we know that for a certain amount of activity how much time is required, how much cost is required. So, that is the project is unique, but activities in the project are repetitive in nature. Like construction, we know that brickwork is required in every construction activity, but each project has different construction, different brickwork requirement. So, duration of the activities are considered here as deterministic. PERT is generally used for research and development projects like missile, project where the activity durations are probabilistic. We are not sure about their durations. 3 time estimates are used in PERT: optimistic time, pessimistic time and most likely time. Optimistic time means considering everything will go as per plan. If everything goes as per plan, how much time it will take to complete the project. Pessimistic time means considering highly unfavorable conditions. If many things go out of control or are become unfavorable, then how much time it will take to complete the project. Worst case scenario, this is the nothing but worst case scenario. This is best case scenario. If you are lucky on every front, best case scenario. Okay. And this is the most likely scenario. If everything as normal it is going, if it happens that way, it will take that much time, that is most likely time. Methodology: define the project and prepare the work breakdown structure, various activities, develop relationship among these activities. Work breakdown structure will give you the various list of the activities. We will get the list of activities. We will get list of activities. And then we develop the interrelationship between these activities, precedence relationship, then draw the network connecting all the activities, assign time and cost estimate to each activity, compute the longest time path through the network, that is critical path, use the network to help plan, schedule, monitor and control the project. Okay. So, this is the various steps in the CPM methodology. What output we are going to get with the CPM and PERT? We will get to know the project completion time, critical path and critical activities or tasks of the project, non critical activities and slacks available for each non critical activity, availability of the resources. Now, we get to know how much resources are required and we can check whether resources are available or not. Project crashing I can do to finish the project in a shorter time with minimum increase in cost, economic trade off of projects, resource leveling to see the uniform needs of the resources, probability that project will be, this is up to, and these are the additional output which are required with PERT. Probability that project will be completed by a specific date. In CPM case, there is nothing like probability case. So, this is the phenomena, this is the output associated with PERT. So, we will get to know the project duration may be at the end we find it is a normally distributed and project completion time is 50 days with a standard deviation of 5 days. Then what is the probability that project will be completed in 60 days? What is the probability that project will be completed in 60 days? So, that we can calculate. We can do the time controls also with the help of Gantt charts, where the project is on schedule or behind schedule or ahead of the schedule. We can do the cost control also to see the money spent is as per the budgets. We will use one concept, we will study one, that is called earned value concept. How much value has been earned at a particular place with the help of earned value curve we will draw, and we will see that how much value has been earned on a particular point and how much cost is incurred on a particular point, and we will compare this vis-a-vis the planned cost and time. Now, let us understand how to draw the network. There are certain rules. So, I will tell you how to draw the network. Two types of networks are there. One is called activity on node, second is called activity on arc. First, let us see with the help of small examples activity on node. A comes before B, which comes before C. How to represent this kind of a relationship? There are three activities A, B and C. So, in activity on node A, then there is activity B and then there is activity C. So, this type of network we have to draw, where A comes before B, B comes before C. So, that is activity on node, a graph for this. Let us see second, A and B both must be completed before C starts. How to represent that kind of a relationship? If A and B must be completed before C start, so I will take A here, I will take B here, and these two must be completed before I start activity C. Before I start activity C, A and B must be completed. Now, let us see the third part. B and C cannot begin until A is completed. So, there is an activity A and B will start only once A is completed, C will start only once A is completed. So, that is the relationship of when B and C cannot start until A is completed. So, that is the kind of a network diagram for that. C and D cannot begin until both A and B are completed. Until both A and B are completed, C and D cannot start. So, the next case is where C and D cannot begin until both A and B are completed. So, how to draw this on activity on node? There is an activity A, there is an activity B. Activity C cannot start until both A and B are complete. So, C will start only when both A and B are complete. Similarly, D will start only when both A and B are complete. So, that is the kind of relationship we can draw when we are having A and B need to be completed before C to start. Now, here C cannot begin until both A and B are completed. A, B and C cannot begin until both A and B are completed. Okay. D cannot begin until B is completed. So, D is dependent on only B. So, this kind of a relationship I can have for this. Now, another case, B and C cannot begin until A is completed. D cannot begin until both B and C are completed. So, B and C cannot begin until A is completed. So, there is an activity A, there is an activity B, there is an activity C. Okay. So, you cannot start B and C until A is completed. D cannot begin until both B and C are completed. So, this is D, this will start only when these are completed. So, this is how we can plot the graph for this particular work, this particular relationship between the activities. Now, let us come to the activity on arc, same which we have drawn earlier, we are now going to draw for the activity on arc case. So, on activity on arc case, A comes before B which comes before C. Now, we are plotting the activities on the arc. So, this is my activity A, and then this is my activity B, and then this is my activity C. Okay. And these nodes are now only representing the start and finish of the activity. So, there is an activity A which start at 1 and end at 2. We can represent this activity A also in our network diagram as 1 2 activity. So, activity A is activity 1 2, activity B is 2 3, where 2 is the start node of the B activity and 3 is the terminal node of the B activity. Activity C is 3 to 4 like this. So, this is called activity on arc. For CPM and PERT purpose, we will use activity on arc network. Okay, very simple to draw, little bit. Now, activity on arc where A and B both must be completed before C starts. So, this is your activity A, this is your activity B, both must be completed before C can start. So, rather than plotting like this, what I can do is I can plot like this: activity A, activity B. Activity on arc require maybe 1 or 2 iterations also, sometimes you are not able to perceive in the beginning, but then after drawing that you can revise it and make it more compact and more beautiful to look at, and then there is an activity C. So, A and B must be completed before C can start. Numbering wise also, we start with the numbering from the left hand side and go to the right hand side. Here when we are doing the numbering, the number of the start node should be lower than the number of the end node. We have to keep in mind in numbering the nodes in activity on arc, that the start node number should be lower than the end node number. Okay, we will see that. So, here how to do the numbering: 1, 2, 3 and 4, and then in that case my activity A is 1 3. So, rule is followed. Activity B is 2 3 and activity C is 3 4 like this. So, 3 activities I can plot where A and B both must be completed before C starts. Okay. Now, coming to the next, B and C cannot begin until A is completed. This is a simple case. Activity A, then once the activity A is done, you can do B and you can do C also, and numbering we can do 1, 2, 3 and 4 like this. So, we can draw B and C cannot begin until A is completed. So, this reflects that particular relationship of the activities. Now, coming to the next, that is C and D cannot begin until both A and B are carried out. This is a very simple thing, we have already done similar to this. So, this is my activity A, this is my activity B. Once A and B are done, we can start C. So, this is activity C and this is activity D. So, like this. So, we can again give the numbers 1, 2, I cannot give 2 here, then I have to give 3 here. So, that will 2, 3, here I can give any numbering 4 and 5. So, this is how I can give the numbering to these nodes. Nodes represent the milestone, nodes represent milestones. Okay. Arc represent activities. Nodes are not consuming any resource, they represent the milestone. Node does not consume any resources. Okay. Activities consume resources, consumes resources. So, we have to keep in mind nodes are only milestone, they represent the completion of a certain stage. They represent the completion of a certain stage. Okay. So, that is the and in this case nodes represent the activities, node represent the activities and arc represent the relationship only, relationships only. Okay. And node represent the activities and arc represent the relationships. So, activity on arc and activity on node. Let us see the next one. C cannot begin until both A and B are completed, and D cannot begin until B is completed. Okay, let us draw that. I can draw like this. This is my activity A, this is my activity B. Okay. So, C can begin when both A and B are completed. So, I can start my C activity here, but here D cannot begin until B is completed. So, D can start, activity D can start once B is completed. It is not dependent on A, it is not dependent on A, it only dependent on B. If I draw it here, I am violating that. If I draw here, this is wrong, this is wrong, because D is not having a precedence of A is not a precedence of D. So, I cannot draw like this. What to do that in this case? In this case, we have to add the dummy activity, in that is one of the important aspect in our activity on arc network. Dummies are required, whereas in activity on node, no dummying is required. So, how I will draw? I will draw activity A, I will draw activity B, and then I know that activity D can start without any problem once B is completed. Now, activity C can start when A and B are completed. If I draw arc here only, it is only A. So, what I have to do is I have to add one dummy activity here, and then if I plot activity C here, so that will take care. Now, C can start only once A and B are complete. Okay. So, like this. So, C can start only once A and B are complete, and D can start once B is complete. So, that is the concept which we have to learn here, adding of the dummy activity when the relationship is such that where it is not we cannot draw the network without the use of dummy. Okay. Now, giving the numbering, I cannot give 2 here, I have to give 2 here, I cannot give 3 also here, I have to give 3 here, because this dummy activity is, this is sometimes shows as DM. Dummy activity is shown as DM is the dummy activity. What is meant by dummy activity? That means, this is used only to show the precedence relationship, it does not consume any resources, does not consume time or any other resource. What is the duration of the dummy activity? 0. The time of the dummy activity is 0, does not consume any time or any other resource. Okay. So, that is a dummy activity. So, numbering 1, 2, 3, 4, then I can give any number 5 and 6 here. So, that is how the dummy is added in this particular case to represent the relationship. Now, let us see the next one. I hope this is clear how to add the dummy and why we are adding the dummy. Now, let us see the next one, where B and C cannot begin until A is completed. So, let us draw A, activity A. then B and C can begin. This is B, this is C. D cannot begin until both B and C are completed. Now, I have to start B and when both B and C are completed. So, I can draw the dummy in any direction. I can draw in upward direction or I can draw in downward direction, and then I can take the activity D. People can make a mistake here of drawing this in this manner. That is going to be a wrong way. I can draw like this A, and then I can take a node here and I can draw these two activity here B and C. Okay. Technically this is okay. This is activity 1 A, and B and C cannot begin until A is completed. B and C cannot begin until A is completed, and then I can take the activity D here. So, as far as the statements are concerned, this represents that B and C cannot begin until A is completed, D cannot begin until B and C are completed. So, that way it is meeting the requirement, but the problem is both the activity B are represented by node 2, 3. C is also represented by node 3. No two activities should be represented by same start node and the end node. That is one of the important requirement. Otherwise, how you are going to represent these activities with the help of these nodes. Both the activities are going to be represented by the same set of nodes. So, that is why this is not a right method of representing the activity on arc network. This is the right method of representing the activity on arc network. Let us take slightly bigger example to draw the network of activity on node. Here we are having taken the 8 activities together. All the principles which I have studied in the previous slides, we are going to apply them together on this, that is activity on node network. So, on activity on node network, there are two activities which can start. There are two activities which can start without any precedence relationship. They do not have any precedence relationship. Immediate predecessor, they do not have any immediate predecessor. So, they can start. Activity C can start only once these two are completed. So, this is activity C. Then D can start from B. So, activity D can start once B is completed. Activity E can start, we can do the activity D once C and D are done. This is C and D, and this we can do the E. We can do the F once C is done. So, I can write F here, and then I can do the activity G once E is done. I can do G here, I can do so, activity G can be done once A is completed. So, this is activity G I can do. Then there is an activity H which can be done once F and G are completed. So, activity H once these two are completed. So, this is my activity on node diagram for this particular project, which consists of 8 activities A, B, C, D, E, F and F, G and H. 8 activities are there in this network, in this project, and there is certain precedence relationship between them. We say that A and B can start any time, C can be done only once A and B are done, D can be carried out once B is done, E can be carried out once C and D are carried out, F can be done once C is there, E is after E and H is after F and G. So, that is activity on node network. Now, let us draw the activity on arc network also for this particular example. So, I have reproduced this diagram which we have produced in the previous sheet. So, same has been we can draw it in a little better manner. Once I have done, now I know how these to be placed. So, I can take them C, I can take somewhere here, and so that I can take D here. Once D is done, then I can take E somewhere here, I can take it here, and from here I can draw F, and from E I can draw G, and I can plot F here, and I can connect them here like this. So, this is how we can do this kind of a network. E, and I can plot here. So, a slightly smoother and better looking and compact kind of a network can be drawn. Once we have drawn this, now we can slightly compressed and expand in different direction, so that it take a good rectangular shape. It is better to give it a good rectangular shape, so that it is good to look at and easy to comprehend. So, I have reproduced this here activity on arc network. Now, let us draw the activity on arc network also here, activity on arc network. Okay. Start with the node. There are two activities which can start without any predecessor. So, activity A and activity B we can start without any problem. Then I have to draw activity C, which is coming from A and B, and I have to draw activity D, which is coming from B. So, B one single. So, I can draw D here. Okay. Then I have to draw C. So, if I draw C like this, it is following only A, but I have to see that it follows B also. So, I will add one dummy activity in this direction. Okay. So, now C is following both A and B. C is following both A and B. Okay. Now, next is E. E follows C and D, and F follows C. So, F I can draw here, which has only one, and then E is having C and D. So, I can draw E here. Okay. And I have to draw again one dummy activity here in this direction. Now, once now coming to the G, G will come after G is coming once E is carried out, and then I have to draw H, which is coming once F and G are carried out. So, I can draw the dummy here, and I can draw activity H, okay, like this. I can combine these two nodes also, so that this dummy is not required. In the initial round you can draw certain dummies, but in the second round you can see that if these dummies can be eliminated. Obviously, these two dummies cannot be eliminated, but this dummy is not required. Let us redraw this network here only with a different color. So, start with this node, we can go to A, we can go to B. From this we are drawing this dummy activity. From this I can draw C, from this I can draw D, and then I can plot the dummy also going in this direction. Then I can draw E, okay, and then I can come here with the activity G, and I can draw here an activity F, and from there I can draw H like this. So, this is the network which we can draw activity on arc network for this particular given project, which is having 8 activities. Now, let us do the numbering of this, sorry, let us do the numbering of this. Let us do the numbering of this. obviously, we can give this number 1, then can I write 2 here? No, I have to write 2 here, because my dummy activity will be 2, 3. The start node of any activity should be a smaller number. Then I can give 4 here and 5 here. I can give 6 here, 7 here and 8 here. Okay. So, this is how I can define my I can draw the activity on arc network. This is activity on node network reproduced from the previous this thing. Activity on node network we have reproduced, and this is so that now you can compare the two also kept side by side. Okay. So, you can compare this versus this one. This is also right, but this is one additional dummy which is undesirable, we can reduce that. Okay. So, like this. So, this is activity on arc network, this is activity on node network. In this sometimes activities are defined in ABCD manner also. Sometimes these two lines can be avoided and you can have one only. I can give the information of these two lines in one line, that is I may say that the following activities are part of a project. What are these activities? I say that 1 3, 1 2, then there is a C is 3 4, then there is D, that is 2 5, then there is E, that is 5 6, then there is F, that is 4 7, then there is H, that is there is G, that is 6 7, and then there is H, that is 7 8. Okay. So, that is how I can reflect this network with the help of these numbers also. Okay. So, with this we get the idea about the predecessors also. So, this is the idea about activity on arc and activity on a node of a good size 8 activity project. What are the rules to draw the network diagram? All the activities are represented by arrow from left to right. You have seen that we are drawing all the arrows from left to right. The arrow line should not crisscross each other. So, they should not crisscross each other. I cannot draw like this. No, I cannot draw like this. This is not permissible. They should not cross each other. So, we have to work out something so that they need not to be crossing each other. The arrows of a network should not form a loop also. I cannot draw a arrow this activity this, then activity this, activity A, activity B and activity C. Okay. I cannot draw like this and then I can say this is activity D. Okay. I cannot do that, because then there is no clarity in this. This is the wrong diagram. There should not be a loop in this. A, you are saying that A can be carried, B cannot be done unless A is done. You are saying C cannot be done unless B is done, and again you are saying that A cannot be done unless C is carried out. So, that is a technically wrong thought process. Dummy activities are used wherever needed to express the precedence relationship. There should not be unnecessarily use of dummies, that will make the network unnecessarily complex. Fulkerson rule regarding numbering should be used. Number 1 is assigned to the initial event when the start of the project. This will create one or more initial events, like here. Let us understand this, or in our previous diagram also we can say that let us say this is a small network which we can take for our example's sake to understand the Fulkerson rule. So, number 1 is assigned to this activity at this node A, B, C, D, E, F and G. Let us say we are having 7 activities to be performed in completion of the projects, and we have to give the numbering. So, it says that number 1 is assigned to the initial event starting with this. After that, it said that delete all the arrows emerging from node 1. So, if I delete all the arrows emerging from node 1, if I delete this, I am deleting this. What will happen? Delete all the arrows emerging from node, this will create one or more initial events. Give them number 2, 3 etcetera. Now, these 2 are there. So, I can give number 2 here, number 3 here. Once I have done that, again delete the arrows which is emerging from the node 2. The arrow which is emerging from node 2 deleted. So, this can be given a number 4. Similarly, we can delete the arrows emerging from 3 and then we can give this node, as number 5. Once that is done, again delete the arrows which are emerging from these nodes and we can give the number 6. So, like this. So, this is how we can give the numbering to these nodes. We draw somewhere in between this also. So, like this. So, this is how we can give the numbering to this as per the Fulkerson rule. Start with 1, delete all the arrows, you will get some new initial nodes, give them the next numbering, that is 2 and 3, and then again move to the next, that is 3 and 4, and keep on continuing this till you reach to the end node. So, now we will so far we have understood how to draw the activities network, 2 types of network, activity on arc and activity on arc and activity on node, and we also seen the use of dummies also in this. Now, we will perform the critical path analysis. So, our first technique which we are going to apply to this to determine the critical activities, to determine the length of the longest path, or also to get the information about the total completion time of the project. So, we will perform the critical path analysis for that purpose. So, as I said, the critical path is the longest path through the network. So, like in this case, when we will determine there are several paths. How many paths are there from start to end? How many paths are there? This is one path. Okay, this is one path which I have shown with the blue color. Let us show another path with the green color. This is second path which is possible. Let us draw the third path with the help of a some other color. Let us see this color. So, third path can be in this manner. So, we are having 3 paths available with us, and we will see that which one is the critical path. For that, I need to have the information about their timings. Let us say for the example sake, if we give some timing to them, let us say this activity has 3 days, this activity has 7 days, this activity has 2 days. Then the length of this red color path is 3 plus 7 plus 2, 9. The path which we have shown with the red color has a duration of 9 days. Another path which we have shown with the green color, let us say this has a 6 days, this is 2 days. Then the path which we have shown with the green color, that is consists of B, D, F. Green color B, D, F. This has a length of 6 plus 2 plus 2, 8, 10 days. Okay, red color path is A, C, F. This is A, C and F. Then there is another which is shown with the yellow color. What is this? B, E and G. B, E and G. Let us say this has 5 days, this has 2 days. How much? What is the length of 6 plus 11, 5, 11 plus 2, 13 days. Okay, like this we are having 3 paths. So, if I am doing in this manner, my critical path will comes out to be this one, path of longest length. So, my critical path will turns out to be this one, the length of the longest path, and the critical activity will be B, E and G. B, E and G will be my critical activities, and for a smaller network we can do like this, but for a big size network manually you may not be able to explore all the paths and it may be difficult. So, we have to understand the algorithm, that is a critical path method algorithm, we will understand that to determine, but I have given you the idea what is meant by the critical path. So, the is the shortest time in which the project can be completed. You have to, in the interviews etcetera, many times it is asked whether the critical path is the shortest path or it is the longest path. So, you have to keep in mind it is the shortest time when the project can be completed. You cannot complete the project in lesser than 30 days. Can you complete the project in 12 days? It is not possible. Okay. You cannot complete the project in less than 13 days, because 3 activities this need to be done, and you cannot perform activity E unless B is done, you cannot do G unless E is done. So, these activities are in sequence one after another, and the time minimum time required, the shortest time required is 6 plus 5 plus 2, that is 13 days. So, you keep in mind the shortest and the longest word. Shortest time required is 13 days, and out of the 3, which one is the longest path? Out of the 3 paths, which one is the longest path? We have identified 3 paths here. Which one is the longest path? Obviously, the critical path is the longest path. This path is the longest path. Longest path is length of the longest path. Length of the longest path is 13 days. So, keep in mind, many times in interview the interviewer may confuse you that whether critical path is the shortest path or it is a critical path is the longest path. You say that critical path is the longest path and this is the shortest time in which a project can be completed. So, that is the right answer to this question, whether a critical path is the longest path or a shortest path. You say the critical path is the longest path and it is the shortest time, the length of the critical path is the shortest time in which project can be completed. Any delay in the critical activities delay the project, we are saying critical path activities have no slack time. So, friends, now we have understood how to draw the network in this session. Now, in the next session we will talk about how to find out the critical path using the critical path method. Rather than enumerating each and every path, there we will apply the method where we will do the forward pass and the backward pass. We apply forward pass and backward pass to determine the critical path. Any size of the network can be done, or rather the students of computer science can understand this algorithm and develop their own computer program also to determine the critical path. So, with this we close this particular session in which we discussed how to draw the network for the purpose of critical path analysis and for program evaluation and review technique, that is PERT. In the next session we will talk about these techniques. Thank you very much.